Okay, the plan is to go over factoring of polynomials and the ever popular quadratic formula. But first, let's play a little bit in one of my favorite websites, GeoGebra. Let's get a handle on polynomials. I can just type a letter A and a letter B and a letter C, and GeoGebra will give me a slider that lets me adjust that variable. And I can even click play, and it'll adjust that variable up and down just to see the effect of that variable. And I can stop the playing of that variable, adjusting of that variable. So we have variables A, B, and C. And we're going to write the formula for a polynomial that looks like this. A times x squared plus b times x plus c. And I can manually come over here and adjust the a variable that's multiplying x squared. And before I adjust it, you can kind of think to myself, how would that affect ax squared plus bx plus c? Well, since it's multiplying x squared, it has the most power, the most effect on this result as I have large negative or large positive values of x, because x squared gets really big really fast. So as I adjust a, I see that that curve changes from curving up when a is positive to curving down when a is negative. And as I make a -5, it goes negative really fast, negative slower, and then right at the point where a is 0, look at that, I have a line. So when a is 0, well, it's like throwing out the x squared part because I'm multiplying that by 0. I can even play that variable by clicking here to play, and I can see a as it changes to positive, all the way up to +5, and then starts going back. I see its effect on my ax squared plus bx plus c. As it goes positive, my curve curves up. Ax squared becomes a large going positive. And as a goes negative, my curve goes negative because I'm multiplying x squared by a negative number. And that'll just keep playing if I just leave that playing. So that's the effect of my variable a. So let's bring that back down to around 1. Okay, that's my a variable. Now let's see the effect of the b variable. That's what's multiplying out the x. And I see, well, it doesn't have a real big effect. It kind of has the curve. It has more of an effect close to where x is 0. Otherwise, it just kind of pushes my curve left and right. Let's zoom in on where x is closer to 0 and think about this. If I zoom in where x is close to 0, the x squared, when I'm close to 0, x squared gets really close to 0, right? If x is less than 1 or greater than 0.5 and less than 0.5, it doesn't have nearly as much effect on the resulting equation. But b, it's multiplying x, has more of an effect. And as I multiply that, I see it's like the slope, it's like b is affecting the slope of that curve around where it goes through the y-axis. Where x is 0, b has an effect on the slope, and it's almost like a line there, but then as I get closer to the curve, it's more of a curve. But if I look close around where it's crossing the y-axis, b is basically adjusting the slope of the line of this function near where x is equal to 0. And I can play b and watch its effects. Slope of about, looks like a line there. Starting to curve, and now starting to look more like a line as I go to -5. So I'm seeing the effect of the b on the polynomial a times x squared plus bx plus c. And we'll stop that when b gets around there. Now, what would the c variable do? Let's zoom out again. The c variable, well, it's just adding a constant to my curve. So it should just be lifting my curve up and down. And yes, indeed, that's what it's doing. I see it just adding to my curve that I already have. It just raises it up and down based on the value of c. It just adds a number to that curve. So if c were 0, I would have a curve that stopped right at 0 when x was equal to 0, right about there. There's where my c is almost equal to 0. All right there. I can't get it quite equal to 0. But if I had c 0 exactly, then I have the equation ax squared plus bx. And it would always be going through 0 where x was equal to 0. So this is a fun way to explore the curve of a function when you're given it as some number a times x squared plus some number b times x plus some number c. And I can play with the values of c, and I think I can play all three variables and watch it affect my curve as each variable changes. And I'm not sure. You can watch each variable change and see their effect on my curve. A, B, and C all changing between various values. C is going down, B is going up, A is going up and down. And you could watch this forever, but we won't. But just this GeoGebra lets you graph these things and just get a feel for what these variables, what these multipliers of the x squared, bx, and the c do to an actual curve. Great place to experiment and just hopefully get an idea of how polynomials work. Now let's go to our text. We want to take a look at the a little more practice at factoring polynomials, and then we're going to come to the quadratic formula. So I'm going to open up my file here, and then I'll view it with you, the polynomials practice. Now this is one that we worked on last time, so I'm not going to do them all, but we'll do a little bit of review, practice of the working through factoring polynomials. So I'm going to display this window here for you in a second. All right, display a window, factoring polynomials. Here we go. Going to do a couple. First of all, we'll go forward multiplying, and then we'll practice the factoring going the other direction. All right, so I'm going to grab my stylus. Just do a little practice for review. Get your brain warmed up here. Remember what we do? We do the FOIL method, the firsts. Multiply the firsts, the inside, or sorry, the outside. FOIL, multiply the FOIL. The inside, that would be these two. And then the last, which would be these two. So first, outside, inside, last. Okay, multiply the firsts. What do I get? 2x squared. The outsides, 6x plus the insides plus 2x plus the lasts. 2 times 3 is 6. These get combined into 8x. So that whole thing becomes 2x squared plus 8x plus 6. And now think to yourself, how would I go the other way? If I saw just this, would I know what I could do to go the other way? Well, here's an easy thing to do. If you see a factor of 2 in everything, the first thing to do is factor out the 2. If I ever saw this, first thing I'd say is, wait a minute, everything's an even number. I can make that to be 2 times x squared plus 4x plus 3. And now I can treat this as a polynomial with a 1 multiplying the x squareds. That makes it an easier problem. Two numbers when multiplied will give me a 3. And when I add them together will give me a 4. Well, I know that will be, let's see, how about a 3 and a 1, right? 1 times 3 multiplied gives me 3, added gives me 4. So I know this is going to be 2 times x plus 1 times x plus 3. And we'll see that that's the same as 2x plus 2 times x plus 3. So whenever you see a possible number being factored out, that can simplify your factoring problem in the long run. So what we did here, we did the multiplying out just for practice, and then treated this as our factoring problem, knowing that it would get us back to this, but I see that that's the same as 2 times x plus 1 times x plus 3. And that's the answer I got by checking if I had to factor this problem, if this were my problem to factor, I could see I could make it an easier problem by factoring out the 2. Let's do another one, again for practice. Let's just recognize right here, this is the same as 2 times x plus 1. Well, so now I know this multiplying out is going to be equal to 2 times x plus 1 times another x plus 1. I can bring the 2 out to the front. Since these things are multiplied, I can bring this 2 out to here. And I see that I have 2 times x plus 1 times x plus 1. And so I have 2 times, well, let's see, first x squared plus inside plus x plus outside, or outside plus inside x plus, well, that is equal to 2 times x squared plus 2x plus 1. And as you do the practice multiplying, you will recognize this form, x squared plus 2x plus 1. You should start recognizing that that is going to be x plus 1 squared. For now, I'll get the emergency broadcast system in here. You're making some noise here. Outside here. Now we're getting some noise. And I can't tell where that noise is coming from. Let's see. Everybody's mute. Oh, there we go. Now let's do another little practice. Now this one we don't see if there's any factoring going around. Don't panic. That's the emergency tests system on the first Tuesday of the month. Multiplying this out. First, 3x squared. Outside, 9x. Inside, plus 1x. And last, plus 3. Just combining these two, that gives me 10x. So what I have is 3x squared plus 10x plus 3. Now I'm going to skip ahead to one that I added further down. A couple that you want to remember. Get through a couple in here. These are special ones. You want to remember when you see this, x minus a 5, or x minus some number times x plus that same number. Let's see what we get. Well, first, x squared plus the outside plus 5x. Inside, that's a minus 5x. And then becomes a minus 25. We see that these two cancel out to 0x. So that becomes x squared minus 25. Whenever I see the difference of two squares, x squared minus 5 squared, automatically think to yourself, oh, that is x minus 5 times x plus 5. So the general form, if you ever see x squared minus b squared, you know that that's going to be x minus b times x plus b. Very handy to recognize the difference of squares automatically can be factored as this. And recognize when I see this, I know that that's going to be x squared minus b squared when I multiply it out. A very handy little fact to know about polynomials. Now here's what I'm throwing in here because it's going to be coming in when we look at the quadratic equation. Let's multiply these out. That becomes x squared, that's the first, x times x, plus outside x times b over 2, plus another b over 2 times x, plus b squared over 4. Well, x plus half of b plus x times half of b plus another x times half of b is equal to x squared plus bx plus b squared over 4. So if I ever see this, I know that that's going to be x plus half of b squared. And that'll come in handy. That's actually part of how they derived the quadratic formula. Let's do another one. Suppose I have x plus a, some number a, plus, or multiplied by x plus some number b. Well, I know that that's going to be my first, that's x squared, plus ax, plus a bx, plus ab. Well, I can write that as a plus b times x. Well, what do I get? X squared plus a plus b x plus a times b. Well, guess what? Whenever I see this format, we remember our little, hey, how do I solve this? I'm looking for two numbers that, when multiplied, give me AB. There's AB multiplied. And when added together, give me this number. Well, I know that my two numbers are A and B, all right? Multiplied, I get AB. Added together, I get A plus B. So that's basically how they derive this little diagram. Whenever I see this, I'm looking for two numbers. When added together, give me this. That's how we derive our little magic X to help factor any polynomial. Okay, now time to do a little practice with some simple polynomials. Going to do both the grouping or slide and divide. Let's do the grouping first here. I see 2x squared plus 7x plus 6. Well, it's nice they gave me a fairly simple multiplier of the x squared. It's not as nice as x squared by itself, and then I could use my magic x, but I can take a look at, let's see, 2x squared. I'm going to have this being two things that added together give me 7. Let's just try 2x squared. Let's try plus 4x plus 3x plus 6. Now, what we mean by factor using grouping is I see that these things, this grouping here, that's the same as 2x Sorry about that. My PC just rebooted right in the middle of that edit. With no explanation of why. Just said it ran into an error. We're rebooting. Sorry about that. So it does say the recording is starting again. That's interesting. All right, now we get my files up here again that I was editing. And I don't need to restore any pages. All right, hopefully they rejoin. I'm going to display this window again and continue where it broke. Sorry, that was a weird restart. That hasn't happened before. Okay, factoring by grouping again. We were on this one if I remember right. And we're doing this, factoring this by grouping. Turn on my pen. Okay, so we recognize 2x squared plus 4x plus a 3x plus a 6. I've decided to group it that way because I recognize that that can be turned into a 2x times x plus 2. And I see that this can be turned into a 3 times x plus 2. Now, they don't really show you how you're supposed to recognize that. We'll go the slide and divide as well and see how we can recognize that. Now I see that, well, 2x times x plus 2 plus 3 times x plus 2 is the same as 2x plus 3 times x plus 2. And voila, I have factored this polynomial. Now let's do the slide and divide as well on this. Here's the slide and divide. Basically, we take that 2 and say, wait a minute, this would be easier if I had a 1 multiplying the x squared. Well, you can take that 2 over and say, okay, for temporary, let's multiply the 2 times the 6 and turn this into x squared plus 7x plus 12. Remembering later on, we'll be dividing by that 2 to get it slid back to where it needs to be in front of the x. But for now, we can do the slide and divide, the slide part of slide and divide, bring that 2 over here, multiply it by the 6 to give us 12. Now we have that standard problem. 2 numbers multiplied give us 12, added give us 7. Well, I can jump right away and see, oh yeah, 3 times 4 gives me 12. So then, with the slide and divide, I can turn this into, then, x plus 3 times x plus 4. But we're not done yet, because remember, we slid over the 2. So to get back to our original, we need now to do the divide by the 2 that we slid over. So this becomes x plus 3 halves times x plus, oh look that, x plus 2. And I can bring this 2 from down here, basically slide it back here and make that 2x plus 3 times x plus 2. And lo and behold, look at that. It's the same as how I got it by grouping. So slide and divide. Let's do another. Let's just do the slide and divide on this one. 2x, slide over to the 2. So that becomes x squared plus 5x plus 4. Two numbers, when multiplied together, give us 4. When added together, give us 5. Well, that would be 1 and 4. 1 times 4 gives 4. 1 plus 4 gives me 5. So I can get x plus 4 times x plus 1. Now, since I had slid over the 2, now I have to do the divide by 2. And this becomes x plus 2 times x plus 1/2 and I can multiply by the 2. That becomes x plus 2 times 2x plus 1. Bring out that, multiply the x, essentially sliding it back to where it belongs. And if we multiply this out, we'll see that we get 2x squared plus 4x plus another x, giving us a 5x plus 2. So slide and divide allows us to factor polynomials when there is not a 1 in front of the x squared. Now, how have we, no one else has come back yet since my reboot. Hoping that they'll come back. Well, it is being recorded. Do one more. Well, actually, let's do a few more because I think this is plenty that needs good practice on. Slide and divide. Bring the slide the 3 over to the 12. That becomes x squared plus 13x plus 3 times 12 plus 36. Two numbers multiplied give us 36. Added together give us 13. Let's see here. 1 times 36, 2 times 18, 3 times 12, 4 times 8, 4 times 9. 4 times 9 gives us 36. 4 plus 9 gives us 13. So that becomes x plus 4 times x plus 9. Checking my texts, thinking someone here lost the connection. Well, was not related to that connection, but it is a student in the class. All right, so we slid over. Remember, we did the sliding over of the 3. Now, because we slid over the 3, now it's the time to divide by the 3. And that becomes x plus 3. That we can't reduce any further, so we get x plus 4/3 times x plus 3. And when we see this fraction, we can turn that into 3x plus 4. Times x plus 3. Now let's see, does it really give us that answer? Let's see here. 3x squared, yep, plus 4x plus 9x, yep, that gives us the 13x plus the 12. So it's a tricky way of getting to the factoring of this, slide, divide, and I'd call this slide back. This is essentially your sliding back when you're bringing that back out of the fraction. Let's do one more in the slide and divide practice. Slide the 3 over to the 20. Gives us x squared plus 19x plus 60. Don't be afraid of the bigger numbers. Well, we're looking for two numbers. When multiplied, give us 60. When added together, give us 19. Well, let's do the factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15. Oh, 4 times 15 gives me 60. 4 plus 15 gives me 19. 4 and 15. All right, so x plus 4 times x plus 15. Time to slide, or time to do the divide part. Remember, we slid over the 3. We divide by the 3. This becomes 5. This becomes 4/3. And I remember that I can't reduce 4/3 anymore, so that becomes 3x plus 4. And this becomes x plus 5. There's a guy, if you look on YouTube for slide and divide, there's one guy gets really excited that, hey, this is so easy to get you the factoring of a polynomial with not a 1 in the front. But it does take practice, and we'll do a couple more, and then we'll get to the quadratic equation. Now here's one that we don't have to do the slide. We can see, wait a minute, we have a factor of 3 everywhere. So let's factor out that 3 first and make our life easier. We don't even have to do slide and divide. I have x squared plus 2x plus 1. Well, I don't have to. Remember, two numbers multiplied give us 1, added give us 2. Well, that's x plus 1 squared. Start to recognize the simpler polynomials. I already know now that that's 3 times x plus 1 times x plus 1. Or I would also accept 3 times x plus 1, that quantity squared. This looks a little scary. That's a prime number there. I can't divide anymore. But let's do the slide and divide and see if it actually can simplify. So slide the 4 over, multiply by the 28. 4 times 20 is 80, plus 4 times 8 is 32. 80 plus 32 gives us 112. 4 times 20 plus 4 times 8. 80 plus 32, 112. So x squared plus 23x plus 112. 80 plus 30 gives us 110, and plus 2 gives us 112. All right, factors of 112, because we're looking for something multiplied, gives us 112, added gives us 23. Well, 112 times 1, 2 times, let's see, that'd be 66. 2 times 66. 3 times, well, if it's 2 times 66, it'd be 3 times 44, would it be? No. 3 times something that ends with a 4. Yeah, 34, not 34. 3 times, oh, 30. Oh, is there not a factor of 3? There may not be a, no, there is not a factor of 3. So there is not a 3 times anything. 4 times, well, 4 times 33. Is that right? That's 2 times 33. 4 times 33. There's not a factor of 5. 6 times, well, am I getting to be anything that when added together gives me 23? Oh, the 33 is 3 times 11. Wait a minute, that's not 4 times 33. And it's not 2 times 66, it's 2 times 56. There we go, 56. That means it's 4 times 28. There we go, 4 times 28. 5 is not a factor. 6 times, let's see, be 6 times 20, no, 6 times 17. Ooh, that sounds good. 6 times 17, 60 plus 56. 60 plus 42. Six times 7. 5 times 7, 35. 6 times 7 is 52. 52. 60 plus 52 gives us 112. There we go. 6 times 17. Oh, took me way too long. 6 and 17. Now, I know that that's x plus 6 times x plus 17. Oh, but I have to slide, or I have to divide now by that 4 that slid over. Now we do the divide by 4. Divide by 4. This becomes x plus, well, I can factor out a 2. That becomes x plus 3 halves. This becomes, oh, I can't reduce 17 fourths anymore. X plus 17 fourths. Well, I bring the factors about to the front in both of them. That becomes 2x plus 3 times 4x plus 17. Now something isn't right here because $80 plus 32, 112. When I multiply this out, I get 8x squared plus 12x plus too many x squareds plus, I messed up somewhere here, 3 halves, 17 over 4. The slide and divide broke on me here. I'm gonna have to come back to that one. I messed up on that one somewhere here. I'm gonna have to come back and redo that. Something went wrong there. Let's do the next one, next three, and then we'll do the quadratic. All right, slide and divide. X squared plus 8x plus, oh, the 3 slides over, multiplied by the 5, plus 15. I recognize two numbers multiplied together give me 15. Added together give me 8. Well, 1 times 15. 2 times, oh, nothing. 3 times 5, and 3 plus 5 gives me 8. So x plus 3 times x plus 5 time 2, divide out that 3 that slid over, x plus 1, and 3x, this turns into 3x plus 5. Checking my answer, 3x squared plus 3x plus another 5x gives me 8x plus the 5. That one worked out fine. So either this one was formulated wrong or I did something wrong in my slide and divide. Slide and divide. Oh, first of all, I see there's a factor of 6 in everything. Let's do that. Factor out the 6 first to make this an easier problem for us. X squared plus 2x minus 3. Okay, two numbers multiplied together gives us a minus 3. Added together gives us a 2. Well, 3 minus 1. All right, so that becomes x, well, it becomes 6 times x plus 3 times an x minus 1. Don't even have to do slide and divide. I have a factor of 6 that turns this into a simpler problem. Factoring out that old polynomial. Now we'll do this last one, then maybe we'll come back here for later practice. Here, I don't have a common factor. Let's do the slide and divide. 6 slides over, multiplies by the 2. So that becomes x squared plus 7x plus 12. Two numbers multiplied together gives us 12. Added together gives us 7. Let's see here. 3 and 4 sound like great numbers. 3 times 4 gives us 12. And added gives us 7. So x plus 3 times x plus 4. Not done yet. We have to slide or divide out that 6. Remember, we had slid over a 6. Now we have to divide out the 6. Okay, that becomes 1/2. This becomes x plus 2/3. Or 2x plus 1 times 3x plus 2. Two x times 3x gives us a 6x squared, plus a 3x plus a 4x gives us a 7x, and plus the 2. So checking my answer, it does multiply out back to be that, verifying the factor. Okay, now it's time to take a look at how we got the quadratic formula. The quadratic formula will save us to be factoring a number, a polynomial. When we want to factor polynomials, if all else fails, we can fall back to the quadratic equation. Now, Here is the quadratic equation. We're looking for the solution to some number times x squared plus some number times b times x plus c. And we want to find out, when is that equal to 0? Basically, what are the zeros of the polynomial? When does ax squared plus bx plus c equal to 0? Well, one answer is, well, when a is 0 and b is 0 and c is 0, I get the answer all 0. So that's always going to be a possible solution. But a, b, and c are non-zero. So what value of x will give us a times x squared plus b times x plus c equals 0? That's what we're looking for. What values of x result in this coming out to be 0? Well, if we had some formula, we factored that polynomial like we were just doing practice of. If we could factor that polynomial to be something like, well, that we know that that's going to be ax plus, I'll call it d times x plus e equals 0. When I'm multiplying this times this, if one of these is equal to 0, that will be a solution to the multiplied together equal to 0. And that's basically what they're saying here is, if I have any formula with two numbers multiplied give me 0, well, an answer or a solution to those two numbers multiplied together give me 0 is either the a is going to be 0 at some point or b is 0 at some point. That's how you'll get the multiplier to be 0. There's two possibilities. When a hits 0 or when b hits 0, such as something like this. When this is 0, I know that the multiplication result will be 0. So I have two solutions when I have an x squared in there, because one side can be 0, and another solution is when the other side is equal to 0. So looking at that, using that 0 property, x minus 3 times x plus 2 equals 0 has two solutions. One possible solution is when x minus 3 is equal to 0. Well, add 3 to both sides and I get, well, when x is equal to 3. Well, another possible solution is when this part is equal to 0. X plus 2 equals 0. Subtract 2 from both sides and I get x equals negative 2. Well, that's what they show in their solution. When one or the other is equal to 0, those are my two possible solutions. So, and we list it in this way. I typically list it smallest number left to right, but they didn't here in this case. The two possible solutions for this entire thing being equal to 0 is when x is equal to 3, when the x minus 3 part turns out to be 0, or when x is equal to negative 2 and the x plus 2 part turns out to be 0. So x equals 3 or negative 2. Two solutions. Another way to know that there's going to be two solutions, or at the max two solutions, is because you have a power of 2 of x. Now let's just take a look at that in my little favorite program, GeoGebra.com. GeoGebra. And let's start a new calculator. I don't even have to sign in to run their calculator there. And I can put x minus 3 times, times x plus 2. That's the curve represented by that function, x minus 3 times x plus 2. And look at that. It crosses 0 at the value of x equals minus 2 and a value of x equals 3. That's where it crosses the x-axis. That's when y comes out to be 0. So when we're solving this, x minus 3 times x plus 2 equals 0, think to yourself, I have that curve x squared minus 3x plus 2x, x squared minus x minus 6. That's the function. When it's equal to 0 is when this side is equal to 0, that x equals 3, or when this side is equal to 0 at x equals negative 2. So when you think of the zeros of your function, think of, well, I have a curve that's going to be hitting the x-axis in two different places. I am solving for the locations of where it hits those x-axes. That's what you're doing when you're solving for this equal to 0. All right, now let's get going here because we want to get to the quadratic equation. The general form of this function, a times x squared plus bx plus c, a, b, and c are non-zero. Well, we need to solve for that. Well, they do that by figuring out, well, there's at least two possibilities. Okay, so let's do that here. Let's put it in the form x squared minus 2x, subtract 2x from both sides, minus 3 equals 0. Well, in order to know what two pieces could be equal to 0, well, I have to factor that. Two numbers multiplied give us negative 3, added give us negative 2. Well, I know that because I practiced my factoring, that's going to be x minus 3 times x plus 1. Multiplied give me negative 3. Minus 3 plus 1 gives me a minus 2. Now I know either x is equal to a 3 to give this part to be 0, or x equals a minus 1, and that will make this part equal to 0. So the two solutions of this being able to be true or this being true is when x is 3 or x is negative 1. This one is even an easier one. I know that when x is 0, both sides are going to be 0. So I can factor that out or recognize that that is equal to x squared minus 9x equals 0, or x times x minus 9 is equal to 0. In this case, x can be 0. That's one solution. Or when x is equal to 9, this will turn out to be 0, and 9 times 9 minus 9, or 9 times 0, will also give me 0. So x is either equal to 0 or 9 to make this come out to be true. When you see an x that you can factor out, you know that one solution is, well, yeah, if x is 0, I get 0 equals 0. So here they show finding the solution to x equals 3 or negative 1. Here they show finding the solution of x equals 0 or 9. Now, because we're getting closer to the quadratic formula, that's going to be the one we're going to memorize. I'm going to actually learn a little song to go with the quadratic formula. When I see something squared equals something, I know that I have two possible solutions. Because a negative number squared gives me a positive number, and a positive number squared gives me a positive number, the square root of d or the negative square root of d are my two possible solutions when I see x squared equals d. Because a negative number squared will also give me a positive number. Therefore, the square root has two possible solutions. There is plus or minus the square root. Now, in the normal world, most of the time we only think about the positive square root. But in the case of the quadratic formula and solving for when this can come out to be true, or you can also say x squared minus d equals 0. Remember, because I have x squared in there, expect to see two possible solutions because I have x squared in there, and the square root does give me plus or minus. So let's take a look at this one. First of all, they factor out the 2, so they get x squared equals 13. Now I know that x is equal to plus or minus the square root of 13. I can use my calculator to give me the decimal for that, but this is usually satisfactory. Square root of 13, 13 doesn't reduce any more than that. So this would be the valid answer. X is equal plus or minus square root of 13. Now it's time to come to the quadratic formula. Now I would love to impress you like I did in high school, writing on the chalkboard to impress my friends. The derivation of when I see this formula equal to 0, I can prove to you that the values of x are negative b plus or minus the square root of b squared minus 4ac all over 2a. But instead of impressing you with deriving that, I'll leave that to yourself. There's plenty of geeks out there online that will show you why this turns into that. To help you remember this quadratic formula, if you don't already have it memorized, is a little song that I found out on YouTube. And I'm not going to search for the YouTube right now. I'll just sing the song for you. It's to the tune of Pop Goes the Weasel. Here's how it goes. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that song, and you will remember the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's going to go viral, I'm sure. One of the best hits ever online of the algebra geeks. Remember that song, and you can solve any quadratic meaning you have an x squared in there plus some value of b times x plus c. Finding when that is equal to 0 is the mission of the quadratic formula. So let's examine this now, because this little formula has some interesting insights if you pay close attention. Remember what happens if you ever get something negative inside of the square root. That usually becomes a nasty non-rational number. So b squared being greater than 4ac will help ensure that we actually have a real solution, not an imaginary number. When you start getting negatives inside of square roots, then things go a little crazy. So they examine that here. But first, they basically find the answer to this formula being this, Well, remember, we first of all put it in quadratic formula format before even trying the quadratic formula. First, we get the x squareds on the leftmost. There's the b. And then we arrange it one more time to get a is equal to 4, b is negative 8, and c is 1. So b is equal to negative 8, and a is equal to 4. Now we can plug a is equal to 4, b equals negative 8, c equals 1 into the quadratic formula. X is equal to negative b, well, b was negative 8, so negative b is 8 plus or minus the square root of b squared, negative 8 squared, minus 4ac, and this is where it becomes very important to watch the signs of a and c. Fortunately, in this case, both a and c are positive, so minus 4 times 4 times 1 all over 2a, which is the 4. With that, now we simply start reducing things. This becomes 8 squared. Well, let's go ahead and do the math. That's 64 minus 4 times 4 minus 16. 64 minus 16 gives us 48. So we get 8 plus or minus square root of 48 all over 2a, all over 8. Well, we recognize here that 48 is 16 times 3. And they show you this. Remember, when I get square root of 16 times 3 inside the square root, that's the same as square root of 16 times the square root of 3. I can separate out, and I know that square root of 16 turns into that 4. So when I see square roots and I see a square inside the square root, I can take that part of it out from under the square root of 16, and then I have the 4/3. I have the square root of 3 left because I can't reduce square root of 3. But don't forget, it's still 8 plus or minus the square root, or 8 plus or minus 4 square root of 3 all over 8. Don't forget there is a plus or minus in there. Now to reduce this a little further, I can divide everything by 4, and I get 2 plus or minus square root of 3 divided by 2. So the two solutions are x is equal to 2 plus square root of 3 over 2, or 2 minus square root of 3, the quantity, over 2. Or you could say x is equal to 1 plus square root of 3 over 2, or 1 minus square root of 3 over 2. This might be a little more preferred because it shows you negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, a little analysis of this helps you to see this thing inside the square root we like to call the discriminant, because when that ever goes negatives, what's inside the square root turns, the square root of a negative number is not a rational number, but is an interesting number that mathematicians actually care about. So b squared minus 4ac greater than 0, and that turns out to be a perfect square, like a 25 or a 9 or 16. Well, then you've got rational solutions. There's no square roots involved. It's plus or minus some number, not inside a square root. If it's not a perfect squared, you have real but irrational solution. Something with like that square root of 3. That's irrational. If b squared minus 4ac is actually equal to 0, well, then you've got b squared, x is equal to, actually, if you got b squared minus 4ac equals 0, then you got x is equal to negative b plus or minus the square root of 0 all over 2a. Well, plus or minus square root of 0 is 0, so you have one solution, b over 2a, when what's inside the square root turns out to be 0. And whenever that's what's inside the square root part becomes b squared minus 4ac, well, there is no real solution. There is a complex solution that mathematicians love to analyze and where we get the wonderful, beautiful Mandelbrot sets. But they are complex solutions, complex numbers with i's in there that we don't worry about so much in this course. So when we care about the answer, all we examine is the discriminant. X is equal to negative b plus or minus the square root of b squared minus 4ac. That's the discriminant. Let's look at what the discriminant is. B here is negative 3. So b squared, 9. Actually, I'll write it out. We'll do negative 3 squared minus 4ac. Well, 4 times a is 2 times 5. So what do we have here? We have 9 minus 4 times 2 times 5. 9 minus 40, or negative 31. The discriminant is negative 31. No real solution, two complex solutions. No real solution. Because all we did was look up the what the discriminant's value was. So 2x squared minus 10, well, how'd they get minus 10x? Oh, so they looked at a different one. They did a 2x squared minus 3x plus 5 equals 0 here, but then they had changed it to a minus 10x plus 5. There, b squared got larger, right? Instead of b squared here, we got b squared minus 4ac gives us 100 minus 40 equals 60. I have basically then the quadratic formula. X is equal to negative b 10 plus or minus the square root of 60, that's b squared minus 4ac, all over 2a, or 2 times 2, 4. I know those are the two solutions, but since I have a radical in there and it's not a perfect square, I know that it's a irrational. There's going to be a square root of some number in there. Well, it looks like we got to stop here. Sorry about the I don't know what happened there. My PC rebooted right in the middle of that first one. Hopefully, Teams didn't lose the recording of that first one, the practice. But I wouldn't be surprised if Teams lost that recording because my PC just had a OS. Didn't give me a blue screen. It gave me a green screen of death that time. All right, have a great day. I'll end it here. And I will send out an email to everyone that at least this last part got recorded. And hopefully I can be there Thursday. With my low-grade fever, they don't want me coming in until this fever goes away, even though I'm feeling decent. Thanks for sticking around. Have a great one. Bye-bye.